Hello my dear students, how are you all? So today we are going to start very important chapter, that is thermal properties of the matters. Right. So let us write the heading of the chapter, thermal properties of matter. Thermal properties of matter. So this is the class. Today we will talk about the meaning of temperature, heat and relation between that. Okay, we'll talk about thermal equilibrium. Okay, and after that, if time permits, we will talk about the thermometry. Okay, so let's start. So what is the temperature? Tell me, what is the temperature in day-to-day life? We come up across this from morning to evening. Okay, we'll say we'll come across the hot bodies and cold bodies. We say this is hot, this is cold. How we decide that? Depending upon the temperature. Or if somebody asks you which temperature is more, which temperature is less. Okay, so we sense it, and from that we can say, so this is a cold body, this is a hot body, this is at a high temperature, this is at a low temperature. Or we measure with some equipments, right? So what is the temperature basically? So temperature is what? A degree of hotness or coldness. Degree of hotness or coldness. Degree of hotness or coldness. Yes or no? So temperature is a degree of hotness or coldness, means what? Because hotness and coldness, these are the relative terms. How do you mean by relative terms? So relative term means what? Suppose let us say this is a 0 degree water, this is a lume water, right? Let us say this is at a 30 degree centigrade, and here let us say boiling water, let us say at 100 degree centigrade. And if somebody asks you, how is this lume water? How is this water? Okay, so if you compare with this, we can say this is the hot water and this is the cold water. Correct or not? This is the cold body, this is the hot body, we can say. And if you compare with these two, you will say this is the cold and this is the hot. This is hotter than this, we will say. Now, if you compare with this becomes a hot body, and if you compare with this higher temperature body or liquid, you say this is the cold. Same temperature is there. Sometimes we say it is a hot and sometimes we say it is cold. Means what? This hotness and coldness depends upon the parameter or depends upon the other liquid with which we are comparing. Okay, so comparison is there. With respect to some, we can say hot or cold. Only one body is there, we can't say. Even though if we say something hot or cold, in our mind we compare with some other liquid. If you compare with the cold, less temperature body, we say it is hot. If you compare with the more temperature body, we say this is a cold body. So this is the meaning of relative. So this hotness and coldness are relative terms. The hotness and coldness are relative terms. Are what? Relative terms. Yes or no? Right? So you note down this. We'll see. So we can say here, if you want, you can write here. Lume water is hotter. You can say hotter than 0 degree centigrade water, and lume water is colder or colder than boiling water. This is the meaning of relative term, means correct or not? So note down this. We'll talk about heat now. Okay, can I hear this? Okay. Now look. Heat. What do you mean by heat? What do you mean by heat? Heat is the energy. Its unit is also what? Joule. Just like work, just like energy, the unit of heat is also calorie or joule. Yes or no? So heat is what? Energy in transit. Energy in motion. Energy. The energy in transit. Energy in transit or in motion. Energy in motion is called heat. Is called heat. Okay. So the meaning of heat in detail again we'll see in thermodynamics chapter. So time being, just you understand the energy which is in motion is called heat. It is measured in joule or calorie in CGS. Okay. Now this energy is in motion means it is in flow. So how it flow? The energy flows. Energy get transferred or flows. Energy flows from one system or one body, one system or one liquid, anything, one system to other when there is a temperature difference. When there is a temperature difference, first of all there must be a temperature difference. If two systems or two bodies are at the same temperature, so temperature difference will be 0. Suppose 10 degrees centigrade, another is also at 10 degrees centigrade, 10 minus 10, 0 degrees centigrade. So temperature difference is 0. So in that case, it will not flow. Okay. So what is basic requirement for the flow of heat? There must be a temperature difference. One body at high temperature, other body must be at low temperature. And in that also, there is a specific direction. Heat flows from hot body or hot system to the cold system, or you can say in temperature system, the energy flows from high temperature body to low temperature body. So very important line you must write: the energy, heat flows from high temperature body to low temperature body or system. Low temperature body or system. This is a very important. There must be a temperature difference, and one body should be at high temperature and another body should be at low temperature, and heat flows from high to low, not from low to high. Just like water, high altitude, okay, water is there in the tank, so it will flow due to gravity from high altitude to low altitude without any effort. But if you want to shift the water from low side to high side, then we have to use some external agency, just like pump. Without that, we can't do that. In the same way, high temperature to low temperature. Okay, so this is the direction of heat. Okay, now, so suppose this is one system at low temperature, at high temperature, and another. Okay, so another system is in contact and this is at low temperature initially. So what will happen? It will get transferred from high temperature to low temperature. So up to what point this process will happen? It will continue. It will continue till the temperature of these two becomes equal. Okay, so temperature of hot body decreases and temperature of cold body increases. And they will have a common temperature T. So this temperature T will be less than this TH and this will be more than this TL. So this body will get energy, its temperature will rise, and this body will lose the energy and its temperature will fall. And okay, and together they will have a common temperature T, and this situation is called thermal equilibrium. And at this time, so temperature T minus T 0, so temperature depression is temperature difference is 0 now. So as there is no temperature difference, so heat transfer will stop. And this condition is called what? Thermal equilibrium. Okay, so just note down this. So you can write down this. Now, what is thermal equilibrium? Thermal equilibrium. Thermal equilibrium. Thermal equilibrium. What is thermal equilibrium? When there is no heat transfer, no heat transfer, no heat transfer. This is also called heat interaction. There is no interaction. Heat is transferred from one body to another body, means they are interacting, we can say. And if there is no heat transfer is occurring, then we can say there is no interaction between these two systems, or there is no heat transfer. So when there is no heat transfer between two systems, between two systems, due to no temperature difference, or maybe the reason may be anything else, not only this. Not, I will keep it in the bracket. Most of the time temperature is same, that is why there is no interaction. But this is not always the case. Sometimes what happens, the boundaries are such that heat can go from one body to another system. So in that case we can say, so temperature difference will be there. Temperature difference will be there. But then also heat transfer do not occur. Because of the boundaries are like that. Heat cannot cross the boundaries. In that case also we can say what? The system are in equilibrium. So that in detail we will see in thermodynamics. Time being what you can say, due to temperature difference, due to no temperature difference, due to no temperature difference, there is no heat transfer, and as there is no heat transfer, we can say these systems are in a equilibrium. Okay, so what we can say? When there is no heat transfer between two systems, then these systems are called in thermal equilibrium. Then these systems or bodies, systems are called in thermal equilibrium. In thermal equilibrium. Main thing is what? There should not be any interaction. There should not be any heat transfer. Then and only then we can say they are in equilibrium. So most of the time reason is what? Due to temperature difference. Due to no temperature difference. Means bodies are at the same temperature. In other way. Okay? Yes or no? So what we have done up till now? We have seen what is the meaning of temperature. And then we have seen meaning of heat, and then we have just discussed with this thermal equilibrium. Let's proceed. Note down this. Now let's talk about one word, thermometry. 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 What is a thermometry? It is the science of branch of physics. It is the branch of physics which deals with study of temperature measurement. Study of temperature measurement. And their convergence, we can say, from one unit to other unit. Okay, so this is what? Thermometry, right? Then calorimetry. Calorie is the unit of heat. Metry means measurement. So it is the branch which deals with the measurement of energy. It is the branch. It is the branch. It is the branch of physics. Branch of physics which deals with study of measurement of or heat measurement. Study of heat measurement or measurement of heat, we can say. Study of measurement of heat. Okay. So these 3-4 definitions we have learned today. So this was the introductory lecture based on thermal properties of matter. So in the next video, we'll talk about the temperature scale, different units of temperature, and how to convert that reading in from one unit to other unit, or from one system of unit to other system of unit. Okay, and we'll solve some questions also in the next video. So till then, goodbye.